Hey everybody, welcome to the second sort of episode, I guess, of Base58 encoding, which is an awesome pun, and everybody should appreciate how hilarious that is. So last week we did core lightning with Nifty Nye, and so she's here as well because this is like a Base58 thing. I'm Cody. I help Lisa with Base58, and I recently started contributing to Fedimint as well. Justin is going to be presenting today. He is our subject matter expert and the creator of the whole lightning side, basically.
Hey, don't laugh when you say subject matter expert. Don't laugh, okay?
Yeah. So Justin, he's like one of the core contributors for Fedimint. He's been working with Eric for I think the last 3 months or so, and like during that time, as he's gotten really familiar with the code base. And Fedimint is like the coolest project in Bitcoin. Like, this is just kind of like everybody, like the moment they start learning about it, like they can't stop thinking about it. And like this is hopefully we can get pretty deep into this stuff. So just okay, Lisa, you got to enable screen sharing, but I'm gonna go through some links for if you want to like start contributing and like see the code base and follow along for yourself and stuff. The screen share is enabled. We can do that.
I'm just closing all the browser windows just to make room. All the terminal windows. We're gonna need everything we got here.
Yeah, the Tmuxinator, did that get figured out?
Oh yeah, that's working. That's
really?
working. It's all working.
Sweet.
Oh yeah.
I think
okay,
Lisa
cool.
just stepped away, but that's because I need to share my screen. But I can't. Lisa, can you share my screen?
Sorry, I just don't want to be distracting. Cool. That's okay. 1 sec. So Cody, you're done. Okay, your co-host.
Awesome. Thank you. So here we go. So if you want to learn more about federated Chaumian E-cash mints, just in general, this is the fedimint.org website. And so this is getting updated. I'm working on some updates for it as well. This kind of like walks through just kind of like the general principle and kind of like the general overview of like a federated Chaumian E-cash mint. And then if you want to look at the actual code inside of github.org/fedimint, there's a couple different repos. The one that we're going to be looking at mostly is Minimint, which is the federated E-cash mint prototype. And this is all written in Rust. And so if you want to join and start contributing and stuff, we just moved over to Discord. And so there's a Fedimint Discord. I'll be posting the links for joining this one in. This is mostly for focusing on actual developer talk stuff. And if you want to look at just like kind of the general like macro thing of like, what do we do? Like, what are the benefits of self-custody versus federated custody and those kinds of things? There's a Telegram group also called Fedimint that you can join. So Justin, over to you to give the overview for Minimint and walk through the code base.
Sweet. All right. So I'm going to post a couple of links here that I'm going to be referencing. How do I do that? There's a chat in here, right? Okay. I won't use these immediately, but these are just some like little notes we put together. And yeah, I'll do some slides, but you don't really need those. Yeah. So I guess
you've got screen share too.
How to describe Minimint? There's like a couple different angles you can go at it from, like what it is, and also what you can do with it. So most people know it in terms of the latter. It's an implementation of Chaumian E-cash, which is like a really old idea that predates Bitcoin by like 37 years or something, like 27 years, something like that. Basically, it's the idea that if there's some like asset and you can get an IOU representing a piece of that asset, and it can be the IOU is like there will be a bunch of IOUs and they're all kind of indistinguishable from the point of view of the issuer. So it has like really interesting privacy properties, and probably for that reason it's never really been deployed, because in the fiat system they don't like that. Privacy is sort of discouraged, and also single points of failure are discouraged. So if you have one issuer, it makes it harder. So one interesting thing about Fedimint is that it's federated, so there's not like one issuer. There's a group of issuers that are sort of work together in a sense. And so that's potentially how Fedimint may get around that. So that's like what Fedimint can do. That's most people are familiar with that. But to me, I guess the way I look at it is it's like a framework for building federated applications. So on Bitcoin. So think of any sort of app you'd want to build. If you want to have like, this app run by one person, that's kind of a single point of failure and maybe not so great in Bitcoin. And in Bitcoin, we can get around that with multi-sig. We can have like, the asset owned by multiple people. And so you can have basically the app run by multiple people. And that's what a federation is. It's basically an app run by multiple people, such that maybe one or two or three or so could misbehave and the app would continue to run. And they would just get ignored. So that's basically, it's kind of like two ways I look at it. Let me share my screen here. And I have some, just share the whole thing, I guess. So I have a couple slides that I used from a talk a couple weeks ago. Can you see these?
Yep.
Okay. Yeah, so I just took a couple slides that I liked from this presentation. It was at this great developer conference called BTC++. You should go to it. When is the next one happening? Do we know?
There's an announcement for an announcement.
It's to be announced.
Okay, so,
to be announced.
Yeah, so there's another one that is, yeah, there might be another one. It was a great conference. And so, yeah, Fedimint, basically the idea is like, how will you, the way I explained it there is how will you access the Bitcoin network? And, most people now, it's like two polar extremes. Either you're on a really untrustworthy central party like Binance or Coinbase or something that doesn't steal from you like literally, but they really do by enticing so many people to buy kind of fool's gold and altcoins and stuff that they know aren't as valuable as Bitcoin. And then on the other extreme is people probably like us who run our own node and use a hardware wallet, stuff like that. And so to me, Fedimint represents something in the middle. And I love this post by Hal Finney where he's talking about, this is 2010. He's talking about why there are going to be Bitcoin banks and why it's a good idea. And so this is kind of like the center ground. The idea of many small Bitcoin banks is sort of unexplored right now. We have a few huge ones, Coinbase, Binance, stuff like that. And then everybody else who's, is their own bank, so to speak. And so, yeah, so that's kind of like a little motivation where I find Fedimint interesting. Like it's sort of Hal Finney's vision for kind of a middle ground between self-custody and, custody with third party that's not trustworthy. So like, a local, something like a bank that is run by people you trust. And if this was like a shared protocol where there could be many instances of this and everyone who uses it benefits from a network effect in terms of all the software that's built on top of it, I think that would be really great. So yeah, I don't want to talk too much about this, too much more on this side of things, since this is like a developer focused thing. So let me hop over to just like kind of like how Fedimint works. So at its core, like Fedimint is it implements like a transaction system, so, sort of like Bitcoin. Actually, let's do some of the things that Bitcoin is not. It's not, or Fedimint is not. It's not a blockchain. It's not a fork of Bitcoin. It's not a side chain. There's no proof of work. There's no mining. It's like think of it as like a replicated state machine, right? So let's say you have 4 members who run something like a bank, right? So people can deposit into it. And then these 4, like anything you can express in software, these 4 people could basically run a state machine, figuring out like what to do with this. So like giving out IOUs to it, giving out blind IOUs to it, integrating with the Lightning Network. You could do all kinds of stuff. You could do blending, all kinds of stuff like that. And it wouldn't necessarily have to be Bitcoin either. You could do other stuff, not in terms of altcoins, but just like any sort of federated app that might be interesting you could do. So yeah, it has this transaction system, much like Bitcoin, and the data structure is very similar. There's inputs and outputs, and then there's one signature for the whole transaction, which is different from Bitcoin. Bitcoin has signatures of each input, and so that's like a cool thing. So this is, I think this is Musig. So we're probably one of the first people actually using Musig. This is a Schnorr-based signature aggregation system, so you get one signature for the whole transaction. So it's like one. This will be a theme on the talk here. And again, if you want to interrupt me, please do. Like I'm used to running these Socratic seminars, so I'm used to being interrupted a lot. So it's a little weird if no one interrupts me. Yeah, so this is like a recurring thing you'll see in this talk is that, or I shouldn't call it talk. This discussion is that we use a lot of these cutting edge tools in Bitcoin. They're like so far mostly used for research. And a great thing about Fedimint is that we can actually deploy all these and use them as they're supposed to be used. You know, we're not just doing it for the fun of it. They're actually, these are the right tool for the job, because here we just get one signature. So it's more, you know, just much more concise. And then, so for example, what's an input, what's an output? So Fedimint is module based. So if you go to the, let's go to the repo. Like if you hop over to the repo, you will see that there's this folder modules. So hop in there. And so we have 3 modules so far. And we have a wallet module, Unchain Wallet, Mint, which is these blinded IOUs, and then a Lightning module, which is allows people who own these IOUs to send and receive Bitcoin with the Lightning Network, which I think this is the part of the system that I've worked on the most. So we'll probably talk about this the most. But so that's a really interesting thing about Mini Mint. And I guess, let me just hop over into the text editor here. And so strut or trait, what is it? Module, what's it called? Where is this? Fedimint module. You know what this is called, Cody? Is it module or? Let me get back to that. What is a? Yeah, I'll get back to that. Oh yeah, Federation module. Okay. Cool. Oh, this is, oh. Sorry, that wasn't Rust code. Okay, Federation module. Sorry for the hiccup there. So this is like what a module is. And so we'll get a little bit into this more later, but every module just describes what is an input and an output to that they register on like the global transaction. And then they also say basically how to, what items they'll pass to their peers as like inputs and outputs to consensus. And then there's a handful of traits that need to be, or functions that need to be implemented in terms of like the actual process of both communicating how this module wants to change the state of the system, and then actually applying it. So actually like updating the local database. That makes sense. So yeah, so what a transaction is, you have inputs and outputs, a signature of everything, and inputs and outputs are defined on modules. And so that's what makes Fedimint to me kind of like a framework, not just like a specific product or protocol or something. It's you could build your own modules and compose it to build any app really. And the app you could have like one server, or you could have multiple servers that allow you to spread the trust around. So yeah, that's basically what Fedimint is at like a very high level in terms of like what how transactions work, stuff like that. I'll pause here and have see if there's any questions.
Yeah, real fast. So this took me a little while to understand for why we have to do the consensus at all, right? So like the internal consensus between the Federation members of like, because right now we're using HBPFT, which is Honey Badger Byzantine Fault Tolerant Consensus Protocol. And like it was kind of like just made by a bunch of shitcoiners. And so it's like, like we're Bitcoiners, why are we doing this thing? And like the reason why is because it's a replicated state machine. And so the Federation has to do the updates of the inputs and the outputs, regardless of what they are across the modules, right? And so like for the Mint, for example, like they have to, across everybody, come to consensus about which IOUs are getting redeemed and which ones are getting issued, right? And so because we've got this like modular framework of that, you could basically just have it be anything. That's how we were able to do Simpiment, where with that one, it was, hey, like the inputs for these things are simplicity contracts. The outputs are the execution of the simplicity contracts. And like, you can pay it with Bitcoin or whatever, right?
Yeah, that's a good one. So just as an example of what else you can do with this is just on my fork. We made this, Cody and I met at a hackathon a couple weeks ago, And as part of the thing, we tried to make our own module. And so we called it Simpimint or mini simp, I forget. We basically implemented, like, if you know pay to script hash in Bitcoin, you lock funds with a hash of a script. And then if you can present that script and like a redeem script that satisfies it, then you are able to move those funds however you want, right? And so we tried some, so that's using Bitcoin script, like the scripting language that Satoshi invented, which has a lot of, it's just not very expressive. It's kind of difficult to work with. And, you know, this is largely why like things like Ethereum were created, is that developers wanted, I mean, there were other reasons, but developers wanted more ability to express different contracts, and it wasn't really possible with Bitcoin script. So for the last 8 years, Blockstream has been making this thing called Simplicity that hopefully will allow you to express many more scripts. But unlike Ethereum and various shitcoins, you can analyze these scripts at, they call them programs. You can analyze these programs statically, like, so not while they're running, but before you ever attempt to run them. You can say like, this program will terminate, which you can't do with I forget the name of the Ethereum one, Solidity, because and that's why they have gas in Ethereum, for example, because you never know if your script is going to terminate, so you have to charge per like execution. So this was a really fun little project because we were able to let's see, implement this trait I showed you earlier. And again, yeah, I was kind of assuming you guys know Rust. I'm assuming you don't know Rust now. So yeah, a trait is basically like a specific set of behaviors that someone could, you know, it's like an interface, an abstract interface, and you have multiple implementations of it. And so this one was really cool because it was very straightforward, right? We didn't have any consensus proposals, I don't think. A lot of it's very similar. And so this was pay to script hash right here, pay to simp hash, pay to simplicity hash. We would go look up an account. We would look up like an existing balance, and we just see if this is when someone's trying to move money out of one of these hashes. We'd check whether they had enough funds to do this. Then we would go check to see if this is like we take the program's ID, basically like a script hash, for example, and check that matches, the ID matches to what locked the funds. And then we would actually go run the script through the Simplicity interpreter and see if it succeeded. And so this is really cool. It's like one of the first actual implementations of Simplicity in a real like environment. So I can see how like eventually Fedimint could be kind of like a general purpose programming environment that it isn't secured by proof of work or proof of stake or any of these other consensus algorithms. It's secured by the fact that you trust the people running it. So it's a very explicit trust model, which I think is nice. And I think there's going to be a lot of there could be a lot of applications here. Like one thing that's really exciting about Fedimint is that the trust model is that you trust the people running it. And so, you know, for most financial applications, what you're really trusting is that the legal system that regulates it is like fair and honest and decent. And the fact is that most of the world that's not true. And so in most of the world, you don't have financial infrastructure. So something like Fedimint, I think, could come in and be really interesting there because I think this could operate pretty well in a place where you don't have like a good legal system, for example. I don't know. That's just an idea. So yeah, this was like, go ahead.
I was just going to ask, when you said that the Federation members, I think, need to reach consensus about the like state of, I guess, like the virtual machine. Is that like in practice, would that be like kind of like a node software that each Federation member runs, like many node that are constantly talking to each other?
Great question, and thanks for interrupting me. This is one of the first, by the way, this is one of the first times I've like gone through this, talked about this really, and I'm still learning. So, you know, please interrupt me because I'm sure I'm going to miss stuff. So thanks, Stephen. Yeah. So yeah. Stepping back, how will this work? So let's say me, Cody, Stephen, and Lisa want to set up a federation. We would each go, this doesn't exist yet, but we would each go, you know, like there would eventually be like a release that's produced, right? We would each go and download this release, just one file, right? Each of us would run this file, and it would probably pop up like a web server, and the web server would say, could you give the like probably the Tor addresses of the people you'd like to use this with? So offline, probably in Signal or something, we'd create a group, we'd all share our address. It would spin up it would probably tell you what your Tor address is. And then so we'd all connect to with each other. And then offline, we would also share our pub keys. It would show this is what your pub key is, right? And you could download it or something. And then you'd share all the pub keys with all your peers. And so that's like the first step. And so now you have like this federation, you know how to contact each other, and you know each other's identities, right? And so I think a nice thing to step into right now would be, we just got some random links here. This one would be pretty good. So this is what like a Minimint config looks like when you run the code, and we'll do this in like a couple minutes here. But I think it's kind of interesting to note. So like you have the locations of all your peers, and these are the pub keys for the various denominations of the these. I'll skip this for now. We'll get into that later. This is for the on-chain wallet. So like the money is held in a sorted multi-descriptor, 3 or 4 multi-sig in this case. This is something that we need to fix the serialization of. I think this is the, yeah, this is the pub. I forget exactly what that one was. And this is a bunch of example stuff about the fees. And this is how many peers are allowed to stop following the rules, basically, before the system stops, right? With Bitcoin blockchains, if there's a disagreement, you get a fork. With Fedimint, it would just stop operating, right? Like if the idea was that 3 of 4 had to follow the rules, and then 2 stopped following the rules, it would just stop, right? You wouldn't be able to move forward. Does that make sense? And so yep. once all 4 people run the software, generate a configuration like this, then they just start exchanging messages from each other. And this is a part of the system, the consensus, that I'm not as familiar with. But I think the first thing you would do is, let's see, the first thing you would do is, actually I can probably module wallet lib, I think would have it. So you'd start gossiping about what you think the current block height is. One cool thing about Fedimint is that it has very low requirements for what it requires the blockchain. Like some apps need a transaction index, address index, all these things. Fedimint only requires the header chain. Like what headers has your block? Like what is the current chain tip? That's all that's required, which is pretty cool. So yeah. So to answer Stephen's question in a little more detail, when these 4 peers run this, one of them would need to set up they would each need some like source of block headers. So, I mean, you could potentially use block explorers. You could run Bitcoin D locally. You could do a prune node. You could do stuff like that. I forget where this is. But yeah, there's like one of the first things you do is you'd start talking to Bitcoin D, and you'd figure out what the chain tip is. And then you'd start gossiping that around your peers and make sure you agree on that. Because the first thing the system you do is someone would deposit money into it. And in order for that to happen, all the peers have to be agreed on what the current block height is, for example. And yeah, I'll get into the different modules in a little bit here, but that's basic answer to the question.
Yeah, just a side thing is that it's not the current chain tip. So when Justin describes the current chain tip, within the federation, they're 100 blocks behind what the current chain tip is, because the federation, the consensus model that they use, they can't deal with a reorg. Right. And so it's the same thing with Liquid, where the Liquid Federation is you require 100 confirmations on top of a transaction in order for the federation to treat that as settled. Right. Because right now with the replicated state machine across using the HBBFT is that if there were like a 2-block reorg or something, right, like there is no mechanism for getting the E-cash tokens back. Like we use IOUs and E-cash tokens interchangeably. Like once you issue the E-cash tokens, like I have no idea who I've given them to. I can't link those to the ones that are getting redeemed at the end. So you have to make sure that before you issue the E-cash token, that transaction will not get reorged out of the chain. So the federation currently is just trailing behind by 100. And so that becomes a big issue until, like, as Justin's going to get into with the Lightning module, where the Lightning module allows you to, with the E-cash tokens, pay things instantly, right?
Yeah. So this is like the first thing you do is you basically all try to get consensus on what the block height is. This is what I was looking for, as Cody was describing. So yeah, if you're lost, think of it like it's very similar to Liquid, as Cody said. It's just like it's very similar to Liquid. Okay, so where should we go next? I think we have a little bit more on this structure thing. So any more questions about just the basic structure of how Minimint or Fedimint works?
Can you just walk through like an example transaction of like if I want to deposit into the mint, then like what would happen?
Yeah, let me think how to do that best.
I had a quick question around like the Federation and the Guardians. If say like, you know, for like a quorum like fails for whatever reason, like not like malicious at all, it's just servers fail or whatever, can you just start it back up and things run smoothly, like continuing, or is it like a kind of catastrophic event if like, you know, all of the Guardian nodes like go offline?
It should just continue on. It should just continue onwards. I'm not sure if that's.
Yeah, that was my answer in the chat. Is that for HVVFT is asynchronous. It has no synchronous assumptions, and so if everybody goes offline, then once they all come back online, it will just continue where it was previously. Versus something like Paxos that requires synchronicity assumptions.
Okay, awesome. Thank you.
Yeah. Yeah. So that's we use this thing HVVFT, which Cody understands better than I do. And it is one of the few things that I've seen come out of shitcoins that seems like an actually positive contribution. It seems like very high quality code. It's in Rust, which is great for us because our whole project's in Rust. Yeah. So yeah, it's kind of like built to, as far as I understand, it's built to be able to run in like very adversarial and inconsistent network conditions, which is, I think, a good assumption if you want something to be deployed widely in like smallish federations, you know, not like one huge one. Like Liquid is one huge federation, right? Someday there will probably be 100 members, 1,000 members or something. Hopefully this will be many of them and maybe a little smaller. Any other questions?
Yeah, just on the size of federations, is Kitman, he was running tests for this one, and he scaled it up from, I think it's currently like the normal testing we do is like 3 of 4, but he scaled it up. I think it was to like 100 with allowing 20 to be evil. And he said like that the latency between those two was like, you know, it went from like sub-second to like 2 seconds for each consensus round or something. So.
Yeah, so there's some other interesting things here. So Fedimint right now, from our limited profiling and benchmarking, it can do about 5 transactions per second on like just a relatively normal like server, which is pretty good. Like it can at this point without, you know, we haven't done a lot of optimizations. You know, it just as a Fedimint has not been deployed. I don't think it's been run on mainnet yet. I'm not aware that it's been run on testnet yet. It's been deployed on reg test, but that's about it. So it can do about 5 transactions per second, which is kind of in line with Bitcoin. So if you think about, so yeah, with Fedimint, it has a couple interesting properties. Like it's very good for scalability, right? Because like imagine like each one of these sort of can facilitate as many transactions roughly as Bitcoin. So if you have a bunch of these, you can have a lot of people. It's not as good as working on Bitcoin itself, but you can have a lot more transactions happening, which would be very cool. It's good for privacy, and then it's also good for like custody. So yeah, let's do a deposit. Let's see if I can find peg in. So if you want to contribute, one of the best places to look is Minimint integration tests.rs. Actually, so I got a little off track here. Let's probably be better to let's try to do something a little hands-on right now. Yeah, I got like slightly off track here. Let's try to. I'm gonna try to. I'll actually like show you how to play with Fedimint a little bit.
Sheena.
Who's that?
Yep, you're good, Justin.
Okay. Okay, so let's open up the README and where is the first one? Yeah, so we have this cool setup. Like, so Fedimint as a software project is a little complicated because It requires Bitcoin D running it. It doesn't require it, but we use Bitcoin D because it's simple. We have two Lightning D instances. Who, one of them represents is sort of like connected to the federation. One of them represents sort of like an arbitrary node on the network. And then we have 4 servers running, 4 of these servers running. Then we have like we want to interact with them. So yeah, so it's sort of difficult to set that up. So in the last week or two, we've really been trying to improve this, and we're using this thing called TMUX, which allows you to have multiple windows in a terminal. So let me see if this works. So //scripts tmuxinator. I'll just show you what this, or yeah, if we run this, let's see if this works. And we'll just sort of like let's just walk through the tutorial, and I will try to like jump into the code in a couple places. So this requires you to have, I believe this requires you to have the Nix package manager installed here. So you might not be able to follow along, but just give it a second. And Zoom really hammering the CPU here. Okay, cool. So TMUX has 2 windows. You can hit Command or Control B. Okay. Can you all see this?
Yeah.
Okay, so yeah, so here's like a developer environment that we just set up. And so, so here is Bitcoin D. So I'll just like full screen that. So it just like runs Bitcoin D. And this one here is a Lightning network, Lightning daemon. And this one's like connected to Fedimint. I'll get into that later. This one's like just some random node. And then this one, here's our federation. So let's like just go in and look at what happened here. So, why is this? Okay. I'm not a super good TMUX user, so I'm, okay, there we go. So we can see, let's see the entire history here. Okay, so yeah, this is kind of interesting. This is like starting a new federation. So like one mint started, all the 4 of them. So there's 4 instances. This is a 3 of 4 federation, and so you can see this is like an epoch. And so everyone basically says, okay, this is what I think the current block height is, right? And this is required to get anything else to happen. And so you can see each of them prints it out, and hopefully they're all in agreement. And there's some more logging. And then they say, okay, now I think it's 10 more blocks have passed. I think this was, in Bitcoin Core, you need to mine 101 blocks in order to do anything. Here we opened a Lightning channel. So we just mined 10 blocks to get that confirmed. Here we might have opened another Lightning channel. I'm not exactly sure. And now we have like a couple transactions happened to like get everyone with some balances. So let's hop back to the README and just like walk through this. So that's pretty cool. Any questions about this as like a little developer environment? Okay, cool. So we have some stuff defined here, like Mint client is just a client, a little client we have to talk to the federation. So when I run this, it goes and basically contacts every single server. Or actually, I think this one just looks directly into the database. So yeah. So at this point, the environment, we have these little tokens. They're like little IOUs. And right now we have, how many is this? About 10,000 sats of these little tokens, and they have the different denominations. We saw that inside the config file. So basically, like these, yeah. Let me show you how these work, and then I'll hop back to my slides and try to explain that. So let's try to like move some of these little tokens. So let's copy this next one and spend. So oops. Actually, let me go over here. Do it over here because TMUX makes it difficult to copy. So basically what this is it's like, I forget exactly what's in here. It's like a signature. So then we can say mint client, like reissue. And I think at this point we can fetch, and we basically get a new copy of the coin. So this is how a transaction would work if it were peer-to-peer, right? So like you would create this, basically this like little, it's like a little approval to spend. This like gives someone authority to move these coins. And then you could go back to the mint and say like, okay, someone gave me this. I would like to get reissued tokens that the sender couldn't give me, right? So I would like to basically redeem my IOUs in a way that the guy who sent them to me can't take now. Does that kind of make sense?
Yeah, can you just really quickly, because we didn't cover it before, was the privacy aspect of this, of like, why do we have to do the round numbers and why do we have to ping off the mint every time we want to get the spend?
Now that I get into this call, I realize it's like so hard to describe this because there's so many different like aspects. It's hard to go in. I don't know. Like let's ignore the privacy for a while and just think of like this as like this is like an IOU to some tokens, to some Bitcoin. And if you give that IOU to someone else, they can go to the mint and say like, okay, here is a valid IOU. Could you just exchange me out a new one that the person who gave me this IOU can't take from, can't take it from me? Does that kind of make sense? Let's cover the privacy here in a second. Let's just go through the README and cover all the stuff. Let's do, okay. So let's try to do like the whole life cycle here. So yeah, this is how it would work.
So to be like, the sender is making the spend command and the recipient is issuing that reissue command. Is that right? The sender does spend, gives them that code. Yeah.
Yeah, so this is how it would work in like a traditional Chaumian mint. So like this is basically like an IOU. Anybody who presents this to the mint like could turn this into Bitcoin. That's a good way to say it. If you have this, you could turn this into Bitcoin, 40,000 sats. Or 400 sats. So this is all millisats, right? So this is like a bearer token to some Bitcoin, and there's some really cool privacy aspects. So basically, here's the thing: anybody, if they're two different, so let's say I do it again, spend 4,000, right? Like let's see these two, this one and this one are different. Let's say Alice made this one, and Bob made this one. If you were to if Alice and Bob were to go and give these to the mint, the mint would say, okay, I know you own 400 sats. We custody 400 sats for you. And we will draw it to your, like, forgetting that 400 sats is like basically the dust limit. Like we will allow you to withdraw this. And the cool thing is they wouldn't know that this was Bob or Alice or this was Bob or Alice. They would just know it's one of the members of the mint. So that's the really interesting thing here is the IOUs are blinded. Let me like hop over here a little bit. So yeah, so basically like what I was just showing you was, so you guys probably covered digital signatures in Base58, right?
We're about to with the new class, but the old ones have.
Okay, cool. Yeah, so really simply, it's like, basically it's, think of it, it's like, just look at the right side of this, right? A signature is you have a secret and you're able to produce and a message, and you're able to basically produce a proof that you have this secret without revealing it. And so in this context, the person that's signing is the mint. The mint. They own Bitcoin and they give out IOUs to Bitcoin. Does that make sense? And so every IOU is a signature. It's like, hey, this Bitcoin is real. And so you could do, like, for example, if you start a webcache, webcache.org. I think this is basically how it works. Is there's a central server that just gives out more or less. It's not IOUs to Bitcoin, but it's kind of like IOUs, signatures. And you're able to just like swap these. Anybody with a valid signature is able to give to the mint. The mint will say, okay, I remember this signature. I won't let someone double spend it in the future. And I will, maybe give you, or allow a transaction to go through, right? And so what a blind signature is, and that's what makes this interesting. That's why Mint, like the Federation can't tell the difference between these two, is that there's an extra step here called blinding, right? So you have an initial message, and then you blind it. I think it's basically even like addition here. I think it's like some fancy kind of addition. So you like add something to the message, and now the message, you can't see what the original message was, right? And now you send that over here to the Mint, they sign it, and then they send it back. And this is a blind signature. And the cool thing is this key that you add to your message, you're able to like remove it from your message later. So you're able to get something called or just a regular signature. This is like the Mint gave you a blind signature, and then you're able to remove the blinding factor and get a real signature. And so the cool thing is when you want to go and redeem this, right, this reissue command, that's just basically like, hey, Mint, was this valid? Actually, I haven't tried this before. Let's see what happens if I try to run this a second time. Okay, see a bunch of errors, right? You see that? So this is the whole idea here. The Mint will give out IOUs, and I wonder if that crashed no, it didn't. It'll give out IOUs, and if you try to double spend it, it will cause an error. Did everyone get that? That was cool. I hadn't tried that before. If you try to, double spend one of these tokens, you'll get a big error. And so how the privacy works is that the first time when the Mint issues an IOU, they see a blind message, right? That's what they get over here, and that's what they sign. Then when you go to redeem it, they see an unblinded signature, their own signature. So they can see that they signed it, but they can't see which message was, because this blinding factor is able to be removed by the client. Over here is like the mobile app, for example, and over here is the server. Any questions about this?
Yeah, in the code, if you look at where we're doing this, is we're using BLS for this one, which is also like commonly known as like shitcoin cryptography. But it's like another useful application of that too.
Any other questions on that one? This is like, please ask questions.
Yeah, and then Justin, the for the round numbers, like why you want to do the round numbers for those for the messages.
Yeah, okay, so this makes sense. So this is like an IOU, and it has to be for a standard amount, right? Does that make sense? So like this is just like this is just a message. And so if every one of these, how do you explain this? There's no amount here. And so what you end up is you have tiers of tokens representing different IOU amounts of Bitcoin, right? So that's from, you see over here, where was that little config, right? So this is like a tier. Here's a pub key representing a tier of 1,000. Maybe these are millisat. I'm not sure. This is like 1 Satoshi. This is 10 Satoshis. This is 100 Satoshis, right? And so what the wallet keeps track of is it has a few of these of each denomination, right? So these are 1 Satoshi coins, 10 Satoshi coins, and so on. And so, yeah, you need the, like basically your anonymity set for each one of these is everybody else who owns an IOU of that value. And so, you could just have like a one fixed value, but then it wouldn't be very good for transacting because you couldn't be able to express different amounts. So what we instead have is we have these like IOUs for different values. And so you're able to combine them like they're little actual coins, like traditional coins, like a penny, dime, nickel, into any denomination you want. Excuse me. And yeah, that makes sense?
Yeah, and because we're using these pegs to Bitcoin values and not like, doing an Oracle problem of trying to tie it to dollars or whatever, is that like in the app that you were making, the Flutter app, is that just shows you like a Satoshi's balance. And it's like, the user doesn't have to know that on the back end, the way that we're handling this is that we're doing IOU tokens, that we're moving those around and those sorts of things. It's that they have a claim one-to-one with the value in the mint.
Yeah, so that's a really cool thing here is that in the end user experience of this is going to be just like a really, really simple custodial Lightning wallet that's very private, which is kind of, to me, a sweet spot. Like personally, that's what I would like to use. I don't really want to run a Lightning node, honestly, because it's like, I just want a simple life. And, but I would like to run, I would like to use Lightning because I think Lightning is valuable, but I would just like, so I'd like the custodial experience to me because it's, the payments will just never fail. I don't have to worry about liquidity. I don't have to do any of that, but I would like it private. So I don't want the service that I'm using to see everything I'm doing. And by using this stuff, we're able to achieve, hopefully we'll be able to achieve like some pretty good privacy.
Yeah, I think that kind of brings to like the Lightning aspect of it, right? So like what we covered before was like how you deposit into the bank, and it's like it kind of works like a settlement layer, right? Of like, you know, you have to wait the 100 blocks. You can't you have to do it slowly, all that kind of thing. Like that would be really annoying if every time I wanted to go in and out of the mint, I had to wait 100 blocks or 100, right?
Yeah.
But for Lightning is like, that's a little different. Of there's no settlement really there. It's more just like trading within there between two Federation members, one of whom is a Lightning gateway. So do you want to like introduce the Lightning gateway concept and kind of like start going through there?
Yeah. Let's think how to do that. I mean, I'm just wondering if we should like cover a little bit more. Let's cover like a little bit more how, let's like just go through a unit test, for example, just to give people like a little bit better understanding of how, because like you kind of have to understand, so like, there's a couple steps, right? You have to deposit into some Bitcoin has to be deposited into the Federation before anything interesting can happen.
Yep.
Right. And then once Bitcoin is deposited in, you get these IOUs to that Bitcoin that are kind of indistinguishable, right? For any given tier, like let's say the 10 Satoshi tier, right? There could be a ton of those tokens. And when the mint sees one of them, all they do is that they check off, they haven't seen that one before. And that in the future, if they see that exact one, they won't allow it. But they can't tell like which issuance it came from, right? So you have these IOUs that for any given tier are indistinguishable from all other IOUs on that tier. Okay, so now that we have these IOUs, you can start to do interesting things. For example, you can deposit some of these IOUs into an escrow contract. And you can go to a Lightning node and say, hey, Lightning node, here's 100 IOUs. There's 100 Bitcoin IOUs, 100 Satoshis of IOUs, or let's say like 100,000 Satoshi IOU that is sitting here inside the Federation. It's in an escrow account. And here's a payment hash and a node pub key. If you can go get a pre-image for this payment hash from that node pub key, for example, you can get that 100,000 Satoshi IOU inside the Federation, right? If you can present that matching pre-image to the Federation, then you can get those tokens, right? And so that's basically a Lightning payment. You were able to incentivize a Lightning node operator who you don't need to know at all. You just need to trust that they just need to trust these Federation IOUs will be redeemable for some other form of Bitcoin, for example, like actually real Bitcoin. And they need to be able to actually go get that pre-image, which is how Lightning works. And so, yeah, so that's basically the makings of like a super, potentially very private Lightning experience where you're able to have very specialized node operators that can serve like many people, hopefully without leaking very much privacy. Does that make sense?
Yep.
That does. And I
cool.
had a question. So
go for it.
Just real quick, I think that something that I'm curious about that I think that like your scripts kind of automated was like, if I'm a brand new user that has like, there's an existing mint set up, how do I do that initial peg in to get my like E-cash tokens? Like, how do I get an address to send real Bitcoin to and exchange it and all that?
That's a great question, Graham. Man, so look at this unit test I have right here. So this sort of like, and again, I like test.rs, if you just search on our code base, this is a great place to see some of these scenarios. So we'll focus in on this one, but I just want to show you some of these tests, like peg in and peg out. So that means deposit and withdrawal. So this one basically does that reissue command I was showing you on terminal. Hopefully, yeah. So this allowed like one user to produce their tokens, another user to reissue them, and there should be another assertion that like the original user can't steal them, for example. Yeah, cannot double spend, right? So someone tries to reissue the coins, and then another person tries to do the same thing, and this is probably an error, maybe, I would imagine. So this can't happen twice. So we have other ones like you can make change, right? Like if you have 100 Satoshi coin, you can get 10 Satoshi coins. This is stuff about dropping peers if they don't agree. What are some other interesting ones? This is Lightning Gateway. This is like paying a Lightning invoice. And this is receiving a Lightning payment. So like there's some interesting scenarios in here. So if you want to get a sense for like the different things that are possible in more of a code context, I would highly recommend just reading through this. And if you have like Rust Analyzer or an IDE setup, you can jump to definition, which really helps. So let's go into this peg in and peg out. So Graham's question was, how do you get this whole thing started, right? Okay, so the first thing you do is that the client, let's say, whoever wants to set this up needs to generate an address. And so the really cool thing about this is that basically, I'll just jump into some code here. So it's kind of interesting. So they get this descriptor, right? And so the descriptor was what I showed in the config here, right? So it's just a witness script hash sorted multi. So it's a multi-sig descriptor. And if you've dealt with descriptors, they have keys in them. There are two types of keys. One of them is a ranged key, like an XPub, meaning a key that can produce many concrete public keys or private keys. Or there's like a concrete public key or private key it's just a single one. And this is a single one. And so it's kind of counterintuitive that this would be able to produce many deposit addresses. But what we do is on the client side, the mobile app side, we do this thing called tweaking. We basically just generate a random number. It's actually a pub key, but for our purposes, like just a random thing, and add it to each of the keys in the descriptor. And so that produces a new script, a new multi-sig script that is spendable by anybody who has the private keys in anybody who can produce a transaction with signatures from the original keys here. Plus, they need the possession of these the tweak, the random addition to each key. And so, yeah, I don't want to go too into the details there, but so they generate a new deposit address. Go back here. So generate a new deposit address, send some Bitcoin to it. And so this is interesting. At this point, the Federation kind of like owns Bitcoin, but they don't actually know it yet. Actually, here you need to, I guess, mine some blocks. So mine some blocks. And then what the user does is they go and call this, they peg in. And so peg in takes let's see if I can, it would be good to show the module here. Module.
Yeah. Kind of a side note, just for wallet. If you notice here, is that normally the way that wallets work with HD wallets is that I generate my own addresses. But in this case, it's that you are generating an address, depositing to it, and then telling the Federation about it. And so the Federation doesn't have like an HD wallet where it has all of its addresses. It's basically a random grab bag of addresses that it got from clients. And so that's why like a standard HD wallet wouldn't work for the Federation, and why when Justin and I were doing the Fedimint thing, we were trying to like integrate BDK, but you can't do that because the Federation doesn't have an HD wallet. It's a random grab bag of the addresses that the clients generated and revealed the tweaks for.
Yeah, and so this is how Liquid works. And the reason they do that is so that when you generate a new address, you don't have to wait for all the servers to generate consensus that they all got the same address, right? And so that adds a little latency. I think our current thinking is that maybe it would be simpler. It would lead to like a slightly worse user experience in terms of depositing, because it would take about 1 second extra. But the benefit of using an actual HD wallet would be that backups get a lot easier. Because right now we have to back up the actual private keys, and then each one of these tweaks that are generated every single time transaction deposit is created. So so this is like the key data structure to think of here when the peg-in happens. So they produce this TX out proof, which is basically like a Merkle proof saying there is Bitcoin in this block on this Merkle path inside the transactions of the block. If you looked at Merkle trees, they can specify, like, given a hash, like where in the original data the something is located, right? So they can say, like, it's like a proof that if you believe this block header is in the blockchain, that this is like a proof that there's actually a transaction in that block. But the cool thing is you don't actually need the full block itself. So that means the burden, the burden of running a blockchain is very low for a federation. So you need that, and then you need the transaction itself, and then a couple other things. This is like the actual the random number that they generated. So this is like so the other cool thing here is that it you know, one problem with the HD wallet is, like, let's say an address is generated, like it's a little tricky to prove that it was you that deposited, right? And this is cool because it actually is a proof. It's like, hey, I have this random number that makes this spendable for your wallet, right? So this is basically, oops, that makes it, what happened there? That makes it, it's like a proof that they deposited, right? So this is how a deposit works. You just send this to the Federation, and then in exchange, you'll get these little, you'll be able to fetch these little e-cash tokens, which are, let me hop over here. And again, this is like one of our, we haven't done a lot of presentations yet, so pardon me. So what is an e-cash token? This is pretty interesting. So this is all those little, the little stuff we were looking at in the terminal, right? This thing. It's actually very simple. It's a nonce, which is actually a public key, but it's just like an ID. Think of it as an ID. This is what allowed remember when I tried to double spend this and the Federation yelled at me? The Federation caused an error. That was because this, every time one of these coins is reissued, this nonce goes in a database of all previously spent nonces. And every time a new one is redeemed, we just check against that list of previously spent nonces for double spends. And if that nonce is not in there, then we know that this IOU hasn't been spent yet. And the other thing we need to check is the signature. We need to check, did we actually sign this, right? And so that's this thing here, right? So when you go in, when the deposit happens, you'll produce these. You'll produce a bunch of these messages. I think they're basically these coin nonces, right? And then you'll blind it and send it to the Federation. They'll give you a blind signature, and you will unblind it. And then the combination of this message, this message and the signature, right? Like this here is this. This here, the signature, is this, and that's a coin. So it's cool. It's like a little piece of data that represents an IOU. And like I said earlier, your anonymity set is anybody else who owns a coin at this denomination, right? It's like 1 sat, 100 sat, a million sat, like that. That makes sense? Cool. So let's go back to the test a little bit. So that's what a pagan does. So you basically prove to the Federation, you say, hey, here's a block header and a Merkle proof that proves that this transaction is in the blockchain, and the Federation has a list of block headers, so they can check this against that. And then, you know, having the transaction information allows them to produce a transaction later on to process withdrawals. And then so after this happens, so Pagan will also, so this is kind of interesting. So this is actually preparing a transaction. So we create this coin input, right, with the proof that we deposited. We say, hey, here's proof that I deposited to you. And then we go and say, okay, what's the transaction amount there? And then we call this function submit tx with change. And all that submit tx with change does is it goes and calculates how much money we want to get back. We add up the inputs and say, like, how much money, how much do the inputs exceed the outputs currently, right? And so it applies one output to the transaction here to make them equal, right? So on the input of the transaction is this proof that you deposited Bitcoin on the blockchain. On the output is, I don't think it's exactly like this, but it's basically like a bunch of these coins. You can think of it as like the output is these coins. It's not exactly that, but I think it's close enough for this purpose. Does that make sense? So like the initial transaction on the input side is proof that you deposited Bitcoin. On the output side are these little bearer tokens that you can trade with other people anonymously, or not anonymously, but like with good privacy. That answer the question, Graham?
Yes, it does. And I may be getting ahead of I'm probably getting ahead of myself here, but can you talk about like data, like maybe like recovery and like, so who needs to store what from both the federations, like guardians, as well as like end users? like I'm guessing that the user needs to be able to store all of this like data to prove that you have like these tokens. It's not like you know, like in Bitcoin there's like seed phrases and you can just like delete the data and as long as you have your seed phrase. So like maybe talk about that a little bit if you can.
Yeah, exactly. So I mean, basically right now as it exists. So I just want to stress that this project is very early. So from like your points of view, it's a cool, it's interesting to get involved because there's some improvements to be made. But on the, you know, on the downside is that like a lot of this stuff hasn't been figured out yet. So if you lose these, like basically, let me see if I can, what is it? FM. Okay, so this is like a folder where all of our configuration lives. And so there's a little database file here. It's just an embedded database, a key value embedded database. This contains all your tokens. They all look like this, right? Actually, this is multiple tokens, I think. Like if we did reissue or spend, let's do an amount that we already have. Yeah, so that's a single token. So a single token is this size. So if you lose, so they're currently just stored in a little database. If you lose these, your money's gone, right? Which is not a good experience. And so there's a lot of ideas about how we could basically make this, you know, you could have something like a seed to make these derivable, but the downside is then you're basically back where you started with having to back up a seed phrase. Like a good thing about like custodial things is it allows people to, like in an ideal world, it allows you to lose your, you don't have to keep a piece of data secure, which humans are really bad at, right? But if we do this naively, then you lose your tokens and you're gone, right? So there's a bunch of possibilities here. Like one is you could have like a seed that allows you to read, you know, recover your coins. Another one is let's see how this exactly would work. So I think what you can do is you can like basically like threshold encrypt your seed for it. You can generate a seed which all of your tokens are derived from, and you can have the Federation members threshold encrypt. You can threshold encrypt it to the Federation's pub key, like their combined pub key. And then so assuming that like the Federation members don't all conspire against you to steal or de-anonymize you, which is kind of the whole assumption here anyways, you could make any sorts of basically, I don't want to say KYC, but like some sort of like, you know, go and check whether that, like if somebody loses their phone and needs to re-get access to the coins, like could they prove that they are who they say they are to the Federation members, and that would trigger this threshold decryption of their seed phrase. So that's like, I think eventually that's where we'll end up going, where and that'll be flexible, and hopefully we'll be able to do all kinds of different recovery mechanisms there by threshold encrypting like a seed phrase inside the Federation. So the user doesn't have to store anything, but as long as they can prove to the Federation members in some way or another that they are who they say they are, and you need to link this with the encrypted like seed, then they could recover all their tokens if they lost them.
Okay, that sounds good.
Yeah, but that's like a big kind of research question. Anything you want to add there, Cody?
Yeah, I think just an element of it is that like the thing that we're trying to get here is privacy, both for the user and like from the Federation. And so like, you know, if somebody shows up and is like, hey, I'd like all the information about like the transactions that this user has done, like the Federation can honestly tell them like, I have no idea. Right. But like the other element of that is that if the user shows up and says, hey, I'd like all of my tokens back, they're like, well, I don't know which ones are your tokens. Right. And so like that's kind of the issue, is that anytime you introduce a backup mechanism that like involves the Federation for this one, you introduce a risk of the Federation being able to like unblind sort of like which tokens belong to which user.
This gets to the idea that Fedimint is like over time, different use cases, like you'll have a many modules. I showed how there are 3 modules now. Over time, there will be more modules, and certain combinations will optimize for like secure custody. Because I think this would be like if you removed the like, I think you could make this like a really interesting custodial product. and it would be a little easier if you didn't have the privacy features, but I think you could also do it with the privacy features. You know, so certain combinations will optimize for custody. Other combinations will optimize purely for privacy. Other combinations might purely optimize for scalability, right? Like how many users can this serve? And so like that's kind of a thing that I think is really cool about Fedimint in terms of like a protocol or like a software project, is that I think it could have like a really strong network effect, so that it can get enough developer attention and love that it becomes good, you know, because with all these sort of really ambitious things, the default case is that it's just going to fail and no one's going to care. So that's what I hope with Fedimint, is that it'll be modular enough so that different use cases will be, you can tailor it to different use cases, and then everyone can sort of benefit from each other's development work. Oh, it's a long sentence. I need to get a little. So how are we doing here? How many? Who's?
I think we got. Yeah, on the back half, you want to go into Lightning for it? So
yeah,
because like again for this one, this is like if we had to if we had to wait like 100 blocks to do anything, like this was the problem with like I think a lot of people had with Liquid, right? Was like it's really annoying to peg in and peg out every single time you want to do any of these things. And like while the federation for these, imagine if you had like a 100-person federation and you need like a 75 signature, like you need 75 signatures in order to spend it. Like that's a giant piece of data that you're gonna have to pay for getting the peg out, right? So it's like, where does like the Lightning come into this one that like makes this usable and makes it so that everybody can like actually scale with this thing?
So we kind of went through this peg in, and like peg out, it's very simple. I think you just take your these IOUs you have, you produce signatures with them. You just take all of them, you produce one aggregated signature for every one of these IOUs you have, and then you send that to the federation saying like, here's a proof I own all these IOUs, and here's an address I'd like you to send Bitcoin to. And then these the different federation servers will basically gossip around signatures to a PSBT. And then once all of them have contributed signatures, they'll just broadcast to the network and you have your withdrawal, right? So that's like the deposit and withdrawal, right? We saw on the terminal here how you could get these little tokens. This spend just spits out a token for this amount, right? It just looks in the database and says, okay, here's one of these little tokens representing this amount of Bitcoin, and you can give that to the federation and say like, hey, I'd like a different one, right? So the problem with this is that basically you can't do a transaction with anybody who isn't in the federation, right? Because this is an IOU to specific Bitcoin held by a specific, group of servers, more or less, right? So like if I am in Federation A and Cody is in Federation B, doing this sort of thing, like sending him this, and having him like ask the federation to give him a new one is just not going to cut it, right? This is not useful, right? But it's helpful to understand how it works underneath. And so how would you make this useful? So like, this is kind of how it works now, right? Like you have this consensus algorithm and you have these different modules, and all the servers gossip back and forth to make sure that they agree on exactly the state, like exactly of the system. And then a user can interact with it, right? The problem is that this is kind of like a very local thing. So the idea with Lightning is like, well, what if you had Federation A, Federation B, Federation C, and they could just like exchange these IOUs more or less, but over Lightning. So like over here, or like let's say over here, right? Here's a federation, but here they can talk the entire Lightning network, right? And to someone over here, they don't even know they're in a federation. It just looks like Lightning invoices, right? So this is kind of the idea of how I think it can actually be useful in the real world. The ideal is like you get all the payment conveniences with Lightning, but and the custodial Lightning, but where someone else is running the node, a professional node operator is running the node, but hopefully you get really good privacy, which is usually one of the big downsides of any of these custodial things. Like if they can see everything you're doing, all their financial incentives are to sell that information. So do you really trust that they're not going to follow their financial incentives and sell that information? But the idea of the Chaumian Mint is like, well, they don't have that information in the first place, so they can't sell it. Okay, so let's go into that. Let's hop back to the README and let's look at it. So I'm going to run this. I'm not sure if I actually need to do this. So this is a script that runs a pegin, and this one's okay. So yeah, we have 2 Lightning nodes running. This one here is basically a Lightning node that serves the Federation as a gateway. They hold, we call it a gateway, it's like an LSP. They hold a balance of these tokens, to facilitate outgoing transactions, they will receive these tokens. To facilitate incoming transactions, they will spend these tokens, right? So they basically need to trust the Federation that their IOUs will be redeemed. But the Federation doesn't need to trust the node. And that's an interesting relationship, because that means any node on the entire network could serve as a gateway if it made sense for them to do that financially, or some other obligations they have to the members of the Federation, right? And so this node here is just like any random node. Okay, so well, one of the first things we need, so I just wrote this code like a week, last week. Let's see. So LN1 is like a C Lightning node, right? So it's a LN CLI. So LN1 GW balance. So yeah, this is really cool. Lisa is going to really love this. So we have a Core Lightning plugin, and our Core Lightning plugin registers RPC commands with Core Lightning. So this is like, I'm sending commands to Lightning CLI, and it's basically telling me how many, what the balance is of the E-cash, the Fedimint like E-cash balance of our node. And so let's maybe move over to this wider screen, or no, let's go over here. So I'm going to run the script. The script executes a peg and it deposits. I'm going to try to get 1,000th of a Bitcoin. Is that right? Or 10,000th. And this one says I want you to use the gateway. I don't want you to use like the user client. I want you to give it to this gateway over here. So let's see what happens when I run this. Oh, sorry. This was.
Yeah, just to answer Graham's question real fast, is that does the LN gateway need to have token pool, like a token pool initially? Like, do they already have to have pegged in to the Federation in order to work? I think the answer is no, is that they can just get paid by someone else in the Federation. Is that you only need to peg in if you want to increase the total value in the Federation. But this is a Federation member paying someone else who is now like just getting some coins from the Federation.
Yeah, so they can do outgoing transactions as much as they want, and they don't need to hold E-cash tokens. They'll receive them, but like let's say every time they do it, every time they get to a certain amount, then they just do a peg out, right? And so they only need to hold these for a given amount of time. The way I see it going is, yeah, I mean we're still figuring this out. I wouldn't be surprised if, at least at the beginning, like the first thing that's going to happen is we're going to have the gateway peg in, because that's just the simplest thing in terms of just getting a Federation going. But in the future, like if there is a vibrant marketplace of these gateways, I think what will happen is that there will be multiple gateways for a given node. Probably there will be like 2 or 3, and then whenever a new gateway shows up, they'll just say like, hey, can I buy some of these tokens off one of you other guys just for some Lightning Bitcoin, something like that. So they'll just use their existing Lightning channel balances to get a couple tokens and start playing around. So there needs to be a peg in to get the game started, but I think once it's up and running, it should just all be Lightning. Does that make sense?
Yeah, no, that cool. That definitely does make sense.
Yeah, so sorry, I didn't have this this thing up to, so yeah, I just wanted this I'm still learning to use this. This is very cool. So I ran a peg, and actually it might not be super important to see how this happens, or see how this works. Yeah, let's just skip it. But now let me run this balance command again. And so now all of a sudden we have 9,000 sat. So I guess there's a 1,000 sat fee that just is probably hard coded somewhere. So that's cool. So now our gateway has some tokens, 9,000. So now what can we do with that? So let's hop back to the README. And so yeah, we have the gateway has this balance of these tokens, right? And so let's go to the other Lightning node, LN2, and generate a 100,000 millisat. I guess that's a 100 sat invoice. So I'll go over here. Sorry, I'm not used to TMUX. And for some reason, Core Lightning makes you get new labels every time. Okay, so now we have an invoice from some random node, right? So like in this context over here, right? So like we just got let's say we're these guys. We got a invoice from there or there or there. We don't even know. Just some invoice, right? Okay, and then so now we have an invoice that was just generated by some random Lightning node. And now let's try to pay the Lightning invoice. So, and I pray this will work. Mint, let's do clear, mint, client, ln pay, and it pays the invoice. And so this is our like Fedimint client, right? And this, the cool thing is this is Rust. So like we actually have a Flutter mobile app where this works. So it can run in, eventually it'll be able to run in any app. It'll run anywhere. That's one of the great things about Rust is your code runs anywhere. There's just an RPC command, ln pay. Let's just do like mint client, just as an example. So here are all the commands. This is like peg in address, peg in, peg out, ln pay, ln invoice. These are the commands we expose. And so mint client, ln pay, enter. So cool. Oh no. Did it work? I'm not sure.
I think you had a warning for inbound. It needed inbound capacity. So you might want to just open up another channel between the two.
I'm not exactly sure why that would be. Our developer environment is changing rapidly. So let's see if I can set up test. It should be in here.
Yeah, but what you just did there is that
open channel.
Right now it's that the client just locked some eCash tokens up and is contacting the gateway and just saying like, hey, gateway, you can claim this if you pay this invoice.
Yeah, so I may have, I think I screwed something up, or our developer environment is just like a little iffy. Let's see if this like crashed or something.
Yeah, see where it says like you could not route the payment? That's because the L2 doesn't have incoming capacity. So you have to open up another channel.
It should though. LN2 list peers. Yeah, so this is weird. I don't know. It should be able to receive, maybe Lisa can tell. There should be like quite a healthy channel here. There's one channel. It's channel denormal. Yeah, I don't know. Maybe it's probably just something about my environment. Like for some reason on Macs, like some of this stuff doesn't work very well. Like I don't know. But like if you run this on Linux, everything works great. Maybe we try one more time. It probably won't work, but we could try one more time.
Yeah, see that dead end warning you're getting there?
Yeah, I mean, you get that a lot, though. Yeah, I've had some problems with like, I don't know. I love Core Lightning on Linux, but on Macs sometimes it's a little flaky. Let's try one more time. Oh. Okay. It looks like that might have worked. Yeah, see that like the routing thing did not show up there. So let's see, like LN2 wait invoice. Oh, test 4. Okay, so it paid it. So yeah, this got paid. See that? So like, remember over here, I created a label called test4. I did LN, I pay that invoice. And then if you use Core Lightning, wait invoice, and then the label, here's the WMHV. So yeah, according to the recipient, they got paid. So yeah, I don't know. For some reason, Core Lightning is just a little flaky on Mac sometimes. But that's just, I mean, everything's flaky. This is an M1 Mac, so like everything's a little flaky on here. So I'm not complaining, but it works really great on Linux. And that's where, you know, obviously almost all the deployments are on Linux. So I don't think it's a problem.
Okay. Can you go through the, for how you're generating that? I forget. So what are like the steps for what the client is doing is when they're generating the
great question
voice and stuff,
so
right? Because isn't there like a pub key in there? Or
yeah, another really interesting one for in terms of like getting started as a developer on Fedimint is to look at just search for main.rs and client CLI source main.rs. So this is the CLI. So at the top, you'll see some of these familiar things like peg and address, peg and reissue, some of these familiar things. Like this struct is what generates this this printout, right? Like these are the commands. This is the file that does all this, right? So the one we care about is ln pay, right? So that takes one argument, an invoice. And so there's a couple steps here. This should be moved down lower. This is not important yet. So the first thing is it creates a contract. So it says, okay, this is the gateway I want to use. Basically, the gateway is a Mint pub key. This is the pub key for their eCash tokens. Like when they want to, if you want to like if you want to make some of these IOUs spendable by them, if they do something, you need this. This is their node pub key, like their Lightning pub key. And this is just the API, which they have like a web server at. And so that's like that's basically what you need. That's how like one of these gateways is expressed. And then so you need to pass the invoice. And so what does fund outgoing contract do? It's probably not, this is too detailed to look into it. Basically what it does is it, you take some, actually we can kind of look into it. So you create this, you create an input with some of your balance. So you take some money and you spend it. And the output is a contract. LN output, contract, yeah, so I guess create outgoing contract, okay. So yeah, this is the contract. Basically it says, I have a payment hash, right? A Lightning payment hash, right? I want you, Lightning node operator, this is the eCash token key. I will make my coins spendable by you if within this many blocks, you pay this invoice. Basically, you present a pre-image that when hashed is equal to this, right? And so this is like an escrow contract. You're saying like, hey, I'm going to put some money in here. And you remember where was it? We created an input. Where was the input? Here, we created an input. We like spent some of our money into this contract, and that's escrow. You deposit some money in, and then you, who is your escrow agent? It's the Federation, right? 3 of the 4 Federation members have to, at least 3 or 4, have to, if the gateway submits a pre-image that matches that payment hash within that time lock time, then the gateway is allowed to withdraw the coins you deposited, right? Because that means that they went and completed your Lightning payment for you if they were able to, you know, get pre-image. Does that make sense?
Yeah.
And so that's the first thing. You create this contract, an escrow contract. You lock some money into an escrow contract, right? And then so what happens next? Well, is the Federation going to accept this? Like, are they going to ignore you? You want, before you like tell the gateway about this contract, you want to make sure that the federation like accepts the escrow contract, right? And so that's what this is. It just waits for that transaction to get confirmed. You get an out point, which is just a transaction ID index, and this just polls. I think there's a PR now to remove polling and switch it to WebSockets, but currently it just polls until that's available. And then you basically you do an HTTP request to the gateway. They have an endpoint pay invoice, and you just send them the contract ID. Okay, so pay invoice. Let's go look on the gateway side. So this is on the client, like on a mobile phone. Let's look at the gateway. Okay, so here is the web server. It's very simple. There's one endpoint. And the one endpoint is pay invoice. What does pay invoice do? So when it receives, as I said, a contract ID. Hopefully you guys can see this. Once they get a contract ID, what do? This is a little hard to reason about. The code's a little confusing here because the gateway is like somewhat concurrent. There's like 3 different things happen concurrently. And so what we do is we do message passing, gateway lib. And so like we have this event loop here that just listens for messages, right? And so the message that this endpoint sends is pay invoice, right? Like here's a request ID, and the sender is just something to send the result back over. So, and then we listen for that here. So our gateway gets this thing. It says, okay, if it's a pay invoice, we'll handle pay invoice. Okay, what is this? Or pay invoice. And so we call pay invoice. Okay, what does this do? We have a contract ID. We fetch the actual contract itself. So that was that thing I showed you earlier with all I think it had the invoice in there. It had the payment hash. It had the pub key of the gateway. It had the pub key of the user. Or I forget exactly which pub key it has of the user. It shouldn't be like very doxing. But what does validate outgoing account do? Yeah, I think this just checks that the amounts and stuff match, that with this, the contract is reasonable. This saves information that we're going to attempt to do this in a database. So like if our first attempt to route fails, we can retry. We don't actually implement that yet, but we need to. And then we actually call core lightning. So ln client.pay. This actually runs self.lock.call. So we're just core lightning RPC. We're telling core lightning, our core lightning node, hey, go pay this invoice. And then we get the pre-image. And so once we get the pre-image, we claim outgoing contract with this pre-image. So we say, hey, here's an escrow contract that locked funds in it, awaiting presentation of this pre-image within some timeout. And so we just produce a transaction that like presents this pre-image to the federation, and then we're able to get the user's escrowed tokens, basically. That makes sense?
Yeah, so 2 questions about that. So for this, you're passing the invoice to the federation, and so the federation sees all of the invoice data, right, of like where it's going.
Yeah.
Right.
Yeah.
But and so what somebody were talking about yesterday was whether or not you could blind that, and like would that be that the user would have to generate the onion and like do the pathfinding and all that kind of stuff, and then put that up and like, hey, if you forward this on to the next hop and like finish the payment for me, then you can do it. But as of right now, it's that you just give the invoice to the gateway and the gateway pays it, and it's like free money for him because you're also paying a fee to the gateway right now for them to.
Yeah, so this contract it sort of sucks that you have to the gateway itself has to see the whole invoice because they don't know who is sending it, but they know a lot about they know who the recipient is. So like, let's say you have a federation with only 100 members, and I don't know, somebody is buying something strange, like that everyone in that 100 group community would know who it was, right? Then it's sort of doxing, even though you don't leak who it was. If the anonymity set is relatively small, maybe people can figure out who it was that paid it. And so I was talking with Eric about this today. I haven't thought about that much. Like, we know we need to improve this, but I think there's a lot of great ways to do it. Even so, like, this is this is pretty damn good. So it's just like, okay, you know, somebody in this federation paid that recipient, right? But you still have a great anonymity set. So, or a relatively good one. So it's better in a lot of cases than existing things. But a great thing to do would be to, like, let's say you had, let's say, I don't know, this is going to be kind of crappy. Like, let's say this is the Lightning Network, right? And let's say like the right in here is like the center of the network. Let's say the client, like the mobile app, for example, maintains a graph enough that it knows how to route stuff to this middle group, right? And then like if some kind of like third-party service could say, you know, if you produce paths to the inside, if they could produce paths from wherever that is in the center of the network to the edge, because that's the much harder problem. It's easy to get to the center of the network routing wise in Lightning. It's hard to get to the edge because that's where all the flaky nodes are, and it's hard to just get it's hard to keep all that keep a graph of all that, especially if you're on like a mobile phone, for example. So like the idea is you could maybe exactly how this works. Like on the client side, you'd generate an onion to get here, and then you'd like somehow you'd want to like finish like have like a third-party service figure out how to produce a path the rest of the way. And so what the gateway would see is just the onion to get here, so they wouldn't see who the final destination is. But the third-party gateway, the third-party node would, but all they see is that, you know, someone's requesting like this third-party service. All they would see is that someone is requesting a path from the center of the network to some node on the edge, and they just showed up on Tor. So I think the privacy characteristics of that are about as good as you can get without having the whole graph synced on your phone, which I think for a lot of, like, I think that's going to be a pretty hard thing to do in practice. So yeah, that's like a bunch of optimizations. But the thing is, like, Fedimint is like, we're just trying to get it to work. So there's a lot of stuff like this where it's like, yeah, big to do here, right? Like, yeah, big fix me, you know? It's just not, it just doesn't, we don't do a lot of these things yet. Yeah, so.
Yeah, and the other question I had for this is that for the contract, are you tying it to a specific gateway, or is that just like a contract that any gateway could fulfill if they do the payment?
Sorry, I look at the comments here like once every 15 minutes. Trampoline routing could be nice here. Yeah. Okay. Yeah. It's just. Sorry. What was your question?
So is it kind of like, because like the thing that I'm thinking of is like kind of like like the LN routers, like liquidity ad marketplace sort of thing, right? Where it's like, if you can just put this up and then anybody can claim it, right? And so like anybody, once we get it packaged so that you can run it on Nix Bitcoin, run it on Umbrel, like any of these things you can be a gateway for, then when you just put this up, if you can just have a marketplace of these are all of the federation things that you want to do. And if you're part of any of these federations, anyone can do the payments on these things, right? And that's also because the federation, this is something we haven't talked about, but like if like this presents a way that you can rebalance basically off chain, right? Or like off Lightning Network, if you want to rebalance things, is that you can like move channel liquidity like in and out of this federation, right? If you want to rebalance a channel. And so it's kind of like a single party, like I can just move. It's kind of like me doing my own swaps between the federation and my Lightning channel in order to move this back and forth, right? But so is it tied to like a specific gateway, or is it just anybody who makes this payment could claim the
so currently it's tied to a gateway, and like so imagine what it was like if this happened, right? Like if there wasn't this. Well, like you always have to assume in this scenario how can like a malicious federation member screw you, right? And so like let's say the gateway pub key wasn't in here, the gateway dutifully did their job, they went and presented the invoice, and now the first federation member to sees this. Well, what if they just like quickly went and told all their peers that actually it was them that you know, is the gateway, and they would like the money, right? Like so, like one naughty federation member could front run all the other ones and might get away with that. So this is just it's a commitment to who will receive it. But yeah, it does make the contract worse, because like let's say you want to go allow 5 different nodes, like try multiple different nodes. This would require, after each node you try one node and it fails, Now you have to go back to the federation, wait for consensus, and then try the next one. And, you know, it's just, it's costly in a handful of ways. I'm not sure what we could do to improve this, but I think we could probably improve this. But yeah, this is one of these things where like a lot of the cryptography stuff here, I just kind of defer to Eric. Yeah, ideally we would have any node could do this. But yeah, we just haven't, we're just trying to get it working in sort of a simple use case. Okay. Graham has a question here. Does the Federation have to approve an LN gateway? That's sort of like still TBD. I mean, like if we want to like get into like a little bit of actual, like in terms of contributing, wow, we have a bunch of merged pull requests all of a sudden. There was like 11 earlier today. Yeah, so I just had one pull request here. This is how like gateways can register with the Federation. Like just it's like adds an endpoint for you to just tell the gateway like, hey, I'd like you to list me as a Federation member. And so like right now, this is like totally everyone's included. Eventually, I can imagine a world where you might need to approve them. I mean, I think this would be configurable on a federation by federation basis, right? Like certain federations would say like, yeah, I want anybody to participate as a gateway, with the reasoning that fees will be lower if it's more competitive, right? But in other ones, it's like, I would rather just do it myself, right? Like I'm the Uncle Jim scenario. I have a Lightning node. I know how to do it. I'll just be the one federation for I'll be the one gateway for our group, and that'll be simpler. So in those scenarios, maybe it would you know, new gateway nodes wouldn't be able to show up. But I think you'd have a mix of both. And again, that's like the whole idea here with Fedimint is like every single thing should be tweakable ideally. And it, you know, the risk is then the software becomes sort of flaky. So hopefully we can still make it robust and allow tons of like tweaking. There are tons of stuff. Difference between Fedimint and Minimint, super confusing. The idea, originally Fedimint was the idea, Minimint was an implementation, because this was like a very, you know, project's like almost 2 years old, and still like it's not deployed. So at the beginning it was very like speculative, and now it's getting to the point where it's like, it looks like this is going to be a solid implementation. So we're currently planning to rename the Minimint repo just to Fedimint because it's confusing. They're the same thing. So I don't know, it's like Bitcoin Core. I don't know. We're just going to call the repo Fedimint/Fedimint. And I think Cody might actually be the one to, if he ever escapes Rebase hell, I sent Cody to Rebase hell yesterday or 2 days ago. I'm sorry.
Yeah, no, that was and if you guys haven't seen it, it's like everything that Peter Willa names, he calls mini something. And so Eric just kind of has like a SIPA joke, was like, what if we called it Mini Mint? And then
yeah,
but like the other element for it was that before, like federated Chaumian E-cash is like on Bitcoin was like kind of this generalized idea, and there were some other projects also working on it. But now, like because Eric built this in such a modular way where you can just like Justin was saying, you can use this to build other federated Bitcoin apps, right? That's like now this is like a generalized thing, but somebody could fork this off, make their own module, and that becomes like their own like mini mint or whatever, right? But like this is becoming like just a generalized modular thing that you can use to make whatever federated Bitcoin.
Like for example, if you wanted to have some fun, you could figure out how to run Solidity in here, and you could just like have the entire DeFi ecosystem running on Fedimint, right? Instead of all this like proof of stake garbage, it's just like it's a federation. It's just more explicit, and you know, you can throw away the historical state, and it's probably better for what is actually happening. It's probably a better way of doing all that. I don't think that would be useful, but it would be a good troll.
Yeah.
So like in principle, you could do that, and it would be fine. Like it should work. But yeah, so one other thing. So I want to leave. I want to take off in like 12 minutes probably because I got another call at 7. And I need to change locations a little. So I want to give a little presentation here, like show this. Like this is a cool Core Lightning thing. It's a plugin. So our gateway runs as a Core Lightning plugin. And so why does it do that? The thing I demoed earlier was sending. And so you can do that via RPC. Remember there was that pay RPC. This is different because receiving, we need to intercept an HTLC. So we need to be able, so, okay, I'll show you how receiving works. So we have this command ln invoice, right? What does ln invoice do? it generates an invoice and then returns it. What does generate invoice do? There's sort of two steps here. So we generate a key pair that's going to be like our Lightning node key pair. And this is kind of a cool thing. Like every invoice will have a different node pub key, which is kind of cool. Like we don't have a stable identity. Like the user does not have a stable identity on the Lightning network. It just changes every payment. And then, so how do we get the payer to be able to route the payment through to our gateway node, right? We apply a route hint. We just stick something in the invoice that basically says like, hey, I want you to send it through this node, right? And so that's like in this terminal context over here, that's this guy LN1. So we'll stick their node pub key in the invoice. We build an invoice. I don't know if anything else there is really usable or really interesting. And then so what we do is so raw payments, this is the preimage. We should probably change that to preimage. So basically we create an output. Yeah, we give our preimage to the Federation, and we basically like list it for sale, right? So if anybody ever wants to buy this preimage, we'll sell it to them for E-cash tokens, right? And so this creates a transaction, or this creates a transaction, right? That basically lists our preimage for sale in the Federation. And then we tell the Federation about it and wait for it to be processed, like we did in the pay case. We just like, we're waiting. Okay, actually, this submits the transaction. This just waits. Like, okay, did the Federation accept this contract? Did they list our preimage for sale? Basically, if they did, okay, great. We have this confirmed invoice. All this is an invoice, and the key pair that is spendable there. We save it in the database and return it. And so the CLI gets this confirmed invoice, and they just return confirmed invoice.invoice, right? So that prints it out on the terminal. So maybe over here I can demonstrate that. Mint client ln invoice 1000 foo. I did it over here again. Mint Tmux, you can't 1000 foo. Tmux, you can't. It's really hard to copy when you have side-by-side things. So copy. So now I have a Lightning invoice. Is there like a decode invoice? Is there a way to decode invoices on Core Lightning? I forget. I could show you the route hints and stuff in there.
Decode pay. Decode pay, I think, is the one.
Oh, there she is. There she is. Here's the route hint, right? And so we'll see, so LN1 get info. So here's the pub key and CD73. So this is our gateway pub key. So if we do, so this is our gateway Lightning node, CD73. So we just put this pub key inside our invoice, right? Now we have this invoice, and so actually, let me go over here again because it's a little more fun to watch it over here because you see all this fancy stuff over here. So what do we need to do? LN2 pay that, right? So we're gonna try to pay it. And so let's just make sure we're at the bottom here. So what we should see here is here in the gateway, we should see some interesting stuff. I forget exactly what it says. Yeah, we should probably have more logging. I used to have more logging here, but I removed it once we merged it. This is not super interesting, but yeah, so basically what happens is the preimage, when we list it for sale in the Federation, it's threshold encrypted to the pub keys of the Federation members. And so once the gateway attempts to buy the preimage, okay, let's zoom out a little bit. Okay, so I was over here and I said LN2 pay, right? And so what did that do? That starts routing, it routes to LN1. And so LN1 receives an incoming invoice or an incoming HTLC, right? And so in our plugin, I register a hook called HTLC accepted. This basically tells Core Lightning, every time you see an HTLC, tell me about it, right? And so what happens is I get an HTLC incoming, and there's this plugin. I think I'm the first person to actually use this library to create plugins in Rust. So there's all kinds of little problems, right? Like the callback is goofy, so I have to run it in a task. It doesn't know how to do error handling, so I have to manually do error handling. There's all kinds of little problems, but it works. And so here's my handler. So, okay, here is the message. This is what I get as an argument, HTLC accepted, right? So there's an HTLC and an onion. And so what I do is I go and ask my gateway, like, hey, basically I send this message. I basically ask the gateway, hey, is this for sale? Is this pre-image for sale? Where is the gateway? Okay, so remember how we had this event loop at the bottom? So HTLC accepted is a different, this is what we saw earlier. Here's the new one. So here's the one we're looking at now, HTLC accepted. So look at the handler. Okay, so HTLC accepted. We look in the HTLC and the amount and the payment hash. We attempt to buy this pre-image from the Federation. And then once we buy this pre-image from the Federation, we await for the pre-image to be decrypted. Oh, these are debugged. I was hoping that these statements would show up in the log, but I don't have the log level set. It's sort of fun to watch this happen. That's why I was a little disappointed. And so we wait for the pre-image to be visible to us. And then once it's visible to us, then we're able to get it and pass it to the handler. And so if you look at here, so we have this hook, and then so we get a pre-image, we buy it. So what happened here is that we had some E-cash tokens that we had to put into the Federation, and then the user's wallet is able to sweep these, right? So basically the user received E-cash tokens, we lost some E-cash tokens, but once we send this to Core Lightning, we have a pre-image. Core Lightning knows how to redeem that for an increased channel balance, or in case Lightning Network isn't working, on-chain balance, right? So the gateway, in the case of receives, they lose a little E-cash tokens, but they gain equal or more Lightning Bitcoin. And the opposite is case in the pay sense, right? For when they're paying, they receive, when they're facilitating an outgoing payment, they receive some of these tokens and send like Lightning Bitcoin. So they're basically a money changer between different types of Bitcoin. So yeah, once this gets accepted, this Core Lightning plugins know how to speak this form of JSON, and it's game over. So that's how. So you saw it's paid here, and I think this is the last thing we'll do here. So mint client. This is interesting. So that's the amount. We should have done the balance before, but I don't think the user actually has the money yet. I think we need to do. Yeah, we need to do wait invoice. We should probably change that. So go back here, mint client wait invoice. Wait dash invoice. Fetch. And then info. They should have gotten, so that was the old amount. Oops. Don't know how to use whatchamacallit. So this should have like updated the amounts. This is hard in Tmux. Yeah, so 970,970. And then if we go down to the bottom, their balance should be 970,970. 979,970. So looks like there was like a 1,000 sat fee, but aside from that, they received 1,000 sats or 10,000 or something like that. they received the money. So yeah, that's basically all I have. I mean, yeah, thanks for sitting through the long-winded thing here.
Thank you, Justin. This was super fun. We got 2 last questions in the chat, and I'm not entirely sure what the answers are for those. Yes.
When receiving from LN to Fedimint, this is a situation where the gateway needs to keep a reserve of coins to buy the pre-image rate. Correct. Yep. Correct. That's that's basically the cost of running the gateway. Is it's the time value of the money you could have had in just normal Lightning channels, right? But you should be able to get some fees here. Also, could the receiving Fedimint user dangle the pre-image then not send? No, because they send it to the they send it to the federation, and the federation threshold encrypts it. And I think before during the process, the gateway buys the pre-image. They check if it's like actually for sale. So once again, it's like it's kind of like an escrow type system where like the federation is the honest entity that judges whether or not like things happen according to plan, right? So the gateway does not have to trust the receiving user, they trust the federation. Could it be possible to some sort of send mint client send output, just a bunch of, that's a great point, Graham. That is a great point. It's a bunch of base64, it's hard to parse. Yeah, as you saw in my presentation, I got confused by the base64. I didn't even realize it was multiple tokens. Yeah, no, that's a great point. It should probably be JSON. Once again, like we are like, this was like a hobby project until about 2 months ago. So what if I'm a part of 5 different federations? So I'm assuming that's, he's talking on the gateway in the gateway side. That's a good point. So currently, when you get an incoming HTLC, you'd probably have to go ask each federation, like, do you have, is there a pre-image for sale for this payment hash? And then you'd probably just go and ask them all that. And then you only attempt to, you only make your decision on whether or not you want to buy it once you see whether it's for sale and what's how many like e-cash tokens you get, basically what's the fee. And so, you know, and this is basically the same algorithm if you get like a routing, if you get an HTLC incoming that has nothing to do with the federation at all, right? You want to just ignore it. So that a little more thought should maybe happen there. Like it would be kind of interesting if like the gateway could subscribe to like a WebSocket of like sale events, so that like assuming that like they could hear about HTLC for sale sooner than like the user could give an invoice to a party and they could pay it. Sorry. Okay, well look at Eston. Sorry.
No, that's good, Justin. That's very helpful. And really what I was just meaning by that is like, what if I am part of like 5 different federations just as a user, and just that bare bones like base64 output is like, okay, which of these 5 federations does this belong to, or where can I redeem it? So I was just mainly talking about like more human readable outputs of those like sends or the whatever.
That's a great one. I'll make an issue there. And yeah, that's a great point. You can see that just not many people have gone through our README yet.
I think something else to think about, Graham, is that for when you're saying like being part of 5 different federations, like the idea here is not that like we're like the fact that like this is supposed to be liquid to like the liquidity within the federation should be similar to the Lightning Network. Like you should be able to like do a complete bank run and just like get everything out of any of these federations like the moment that you want to. And so like you should see like a unified balance on the user side, and they shouldn't know that like, hey, maybe like 50% of these tokens or whatever are locked in Lightning channels, 50% of them are the other. Like think like I don't know. I think Justin would probably agree with this. It's like, you know, I don't know if you notice like all of the Bitcoin developers who work on their own projects, all of them, like basically all of their spending wallets, they use Moon Wallet, right? Because it's like, it's just the easiest, fastest one where you're walking around and it's got the unified balance and like, you don't have to deal with all of the like annoying aspects. It's like either use Zeus connecting it back to your own node, but if you're going to do like a hosted solution or whatever, most people just use Moon, right? Kind of the same thing with this.
Yeah, that makes sense. Thanks.
Okay, I think that's a wrap.
Right.
So thank you so much, Justin. This was absolutely amazing.
Oh, that's good. I feel like it got off to a slow start, but we hit our speed about halfway through. So,
yep.
Wow, Raspi Blitz next week. You guys should all RSVP. I know I already
have. Yeah, we confirmed open house for next week for.
Open house isn't going to make it. They've got another contributor. I think his name is Tony or Toby. I was just looking at.
Come on, open house. Come on.
I don't know, something about he's got family obligations or something.
All good. Cool. All right. Well, yeah, thank you, Justin.
Thanks a lot, guys.
And
thanks
I can go over the last, just kind of go over the links again, right? So this is just like some stuff that we mentioned. This is the paper for HBBFT. I posted this in the chat, and I think this will also be in links we post after. But there's a Rust implementation of it, and that's currently what's being used for that one. Fedimint.org. This kind of just got revamped, and it's going to get more revamped over the next couple of days. And this is, if you want to learn more about Chaumian mints and how they kind of relate to Bitcoin and all that kind of stuff, then Fedimint.org is the place to go. The GitHub is github.com/Fedimint/Minimint. And in here, we've got like a getting involved section that has the links to everything that we kind of went over today. But
the key thing is there's the developer Discord. Just join the Discord and hear about it. And we'll try to make like a nice community there. That's the big one.
Yeah. And we do weekly calls on
every
Mondays.
Monday,
Yeah.
But you'll hear about that in Discord. So I would just encourage you, if you're interested, join the Discord. That's where like that's where you could just best base to kind of keep up to date.
Yep. And that's for the code base discussion stuff. If there's just like general Fedimint following along, there's a Telegram group as well. So
for sure.
Cool. Yeah.
Awesome. Well, thanks everyone for your great questions, and thanks for listening to me ramble like an idiot for an hour.
Thanks, Justin.
2 hours. All right. Thanks, Lisa, for organizing. Thanks, Cody, for organizing.
Cool. Thanks.
All right. Bye-bye.
Bye.
Yes.
All right.
That's it.